We are going to look at the LeetCode problem, fruits into baskets. So this problem is categorized as Google's most common coding interview question. So if you read the problem, it's a little bit difficult to understand, but essentially what it describes is you'll be given an array of integers. Each of a value inside the integer represents a fruit. So here, for example, 1 can represent an apple, 2 an orange, 3 a peach, and you're given two baskets. Each basket can hold a single type of fruit, and as you go down into the array, you can keep adding the fruits into those two baskets. But when you reach a tree with a fruit that you cannot fit into the basket, you must stop. So here, as an example, so since we only have one and two, sorry, two different types of fruits, and the restriction is we have two different baskets, all of them can be added. So we return the result 3. But for the second example, you have 0, 1, 2, 2. So if you add fruit 0, we can just add 0 and 1. Once we reach a fruit that cannot be fit into our baskets, we have to stop. So that's why here if we skip the fruit 0 and just add 1 and 2, then 3 fruits can be added. So yeah, essentially this problem is a variation of the sliding window problem in Java. So for this problem, we'll have use a hash map. So this hash map is used to go traverse down the list, keep an count of the fruit and the number of times it has been added, and also a start and an end pointer. So the end pointer will be used to keep track of the ending window, and the start pointer, the start or the starting window of the solution. So yeah, I think it'll make more sense after I start coding it. So first thing we'll do is create a hash map. So this is the oops. So this one you're going to just use to traverse down the list and keep track of the fruit and the index. Another thing we need is the start and the end pointer. So end and the result. So these are three indexes we are going to use, the start and the end index and the result. So while so while we are traversing down the list, we'll keep adding the fruit into the hash map. So the way we are going to do it is if the fruit already exists in the hash map, we'll increment the count by 1. If it doesn't, we'll just set it to 1. So for that, we'll use get_default method of the hash map. And then we'll keep comparing the result every time. So the result will be the maximum value of the current result, or j minus I plus 1. So j minus I plus 1 is to keep track of the current window. So now the restriction that we have is that we only have two baskets, and so whenever the count of the hash map is greater than 2, then we know that a fruit that an extra fruit has been added which we cannot handle. So when that happens, we need to increment the starting index of the window. So So we are going to do a similar way. We are going to add the value for fruits I, and here we are going to decrement the count by 1. So whenever we encounter, so we keep doing it until we reach a point where the value is equal to 0. So because the value is 0, we can remove it from the hash map. So and we increment the count of the start pointer. So yeah, just to recap again, we're going to create a hash map, and we're also going to create three pointers: the start and the end pointer and the result. So the end pointer, this is for this window, we keep increasing it, and we keep adding the values into the hash map. Every time we add, we just make a comparison where, if the result is greater than the current value, then that value is equal to the result. But since we have the restriction that only two baskets are present and only two different types of fruits can be added, so whenever the size has exceeded 2, we need to increase the starting pointer of the window. So that's what we are doing here. We're just starting from I equal to 0, and we keep increasing it and removing the values present at that index until we encounter a point where size is again less than 2. So that way we can just add back the fruit. So yeah, let's try running the solution. Alright, so 3 use cases have passed. Try submitting it. So yeah, that time complexity is O of n, where n is the size of the input array. So essentially we're just traversing down the list once. And the memory complexity is also O of n, since we're only using a hash map.